Okay, everyone, let's talk about abuses of percents. This is the last part of Chapter 3A. And this is just some common sense thing that we need to be thinking about. The first one, there are three basic ones. The first one is a shifting reference value. The example I gave here is that at a store they mark up an item 40%. Later the item goes on sale with a discount of 40%. After the two changes, it's tempting to say that the price of the item is unchanged. Now, why does that not work? Because it is a shifting reference value. Here, the markup is based on the original price, and here, the discount is based on a different value. It is based on the marked up price. And it doesn't cancel each other out. The second one is less than nothing. And that would be when you have, when a store mistakenly advertises 150% off the price of all merchandise. You can't discount it more than 100%. Or, well, you can, but then they owe you money. This one is a little more subtle. Don't average averages. As a general rule, you should never average percents. For example, if you have an 80% homework average and a 60% test average, it's tempting to think that you might have a 70% overall average, but that's not the case because the categories are weighed differently. That's one that would be extremely relevant to you, and we'll talk about some that are a little bit less obvious. Okay, so let's start with the shifting reference values. A pair of jeans is on sale for 30% off the original price of $80, and you have a coupon for an additional 20% off the sale price. Is the final price you pay at the register 50% off the original price? Well, it's tempting to say yes it is, and this is something that stores use on a regular basis for those of us who really, are not as attuned to this as we could be. Okay, but this is going to be a shifting reference value. Okay, so we start off with a pair of jeans is on sale for 30% off the original price of $80. Okay, so in your first phase, and I'm going to draw the circles just to refresh us on that, these are the original jeans that are $80. And we are going to get rid of 30% off. So what that means, if we remember from our prior units, if you're taking off 30%, that means what you have left is 70% is what you pay. Okay, so 70% of the original is the sale price. So that translates into 0.70. The original price is $80 and the sales price is X, which means that the sale price is $56. Okay, so you now have a coupon for an additional 20% off the sales price. Okay, so when we go to our next computation, we have to start with the sale price of $56. And we have 20% off of that. My circles are awful. So this is 20% off, which means what we're paying here is if you get 20% off, then what you're paying is 80% of the sale price is the final price. So that 0.80 times 56 is X, which tells you that your final price is $44.80. Now what we want to know is this 50% off the original price? Well, on that, if we have the original price, and we're going to take 50% off, the original price was $80, which means that we are going to pay 50%. So 50% of 80, which becomes 0.50 times 80, which is $40. So the answer is no. These amounts are not, these amounts are not the same. And it is because you're not dealing with percents. You have to take this and it becomes your new reference value. The compared value here becomes the reference value here, and then you do your calculations again. Okay. Now the less than nothing, again, this is pretty self-explanatory. And we actually explored this a little bit when we were doing percents, like when we did the weight loss. Could you have 120% of the weight loss? Yes. Could you have more than 100% of the people surveyed who liked or disliked something? No, you can't. 100% is all of them. Okay, so if a pair of jeans, let's see, originally cost $80, what does it mean if the jeans are 50% off the regular price? Well, we just did that. That means we would pay 50%. $50 off means that we're paying 50% times 80, which means what we're paying is $40. Or you can say that we're saving $40. If the jeans are 100% off the original, then 100% off becomes 1 times 80, which is 80. So the discount would be all of it. You would pay 0. Then, if you have 150% off the original, you would have 150% off, translates into 1.50 times 80, which is a $120 discount, which means they owe you $40 for buying the jeans. So again, just this one, it really just kind of makes sense. Okay, so we've done a beware of shifting reference value, we've done less than nothing, and let's talk about averaging averages. Once again, this one is a little more subtle. Okay, in baseball, a player's batting average represents the percentage of at-bats in which the player gets a hit. So, example, a certain player gets hits on 20% of his at-bats during the first half of the season and 40% of his at-bats the second half of the season. Okay, so we take 20% and 40%, and it would mean that he got 30%. Okay, it doesn't work like that, and let's see why. Okay, suppose the player had 500 at-bats in the first half of the season. If the player gets hits on 20% of those, how many hits did he make? Okay, well this is pretty straightforward. So we're just going to start with finding he had 500 at-bats. He got hits on 20% of those 500 at-bats. Okay, so we're just going to find 20% of 500, which becomes 0.20 times 500, which is 100 hits. Okay. Well, let's see. The second half of the season, he had 200 at-bats, and he gets hits on 40% of those 200 at-bats. All right, so we're going to find 40% of 200, which becomes 0.40 times 200, which is 80 hits. Well, his total at-bats, we have 500 plus 200. How many hits? 100 plus 80, which is 180. Whoops, and I forgot to total that. Okay. So did the player make hits on 30% of his at-bats? Okay, well let's find out. So the total at-bats is 700. So here we're going to find 30% of 700, which becomes 0.30 times 700, which is 210. So the answer is no. He only had 180 hits. Now, why didn't that work? Well, the reason is because it's the same thing with the weighted average on your grades. This is 20% of 500. This is 40% of 200. Since these values are not the same, you cannot average averages. If the number of at-bats were the same, you could, but you can't with this. Okay, let's go and all right. So let's talk about this. I don't know if this has happened to any of you, but it certainly has to a lot of people. Because of losses by your employer, you agree to accept a temporary pay cut of 10%. Your employer promises to give you a 10% pay raise after a few months. Will the pay raise restore your original salary? Okay, well, let's see. They don't give us an amount, but since we're dealing with percents, it is going to be the same no matter what. Okay, so let's start out with your original salary. And let's just say it's $50,000. Okay. All right, well, what happens first? What happens first is if you get a pay cut of 10%. Okay, well, if you get a pay cut of 10% for the pay cut, Once again, if you need the circle, go for it. This is your original 50,000. And you take off 10%, which means your pay cut, you get 90% of the 50,000, which is 0.90 times 50,000, which becomes 45,000. Okay. But now your reference value is shifting. If you have a 10% pay raise after a few months, what that means is now for the pay raise, you've got a reference value now of 45,000 plus the 10%. So you've got 100% plus the 10%. So it is going to be 110% of 45,000, which is 1.1 times 45,000, which brings you back to 49,500. Okay. So your result here became your reference value here. Okay, and lastly, let's just see if we can identify some of these as what kind of problem there is. So, it's either a shifting reference value, less than nothing, or don't average averages. Okay, so if a team wins 40% of its games and 60% this season and 60% of its game next season, it will have a 50% win rate overall. Well, that is going to be false because you don't average averages. You don't know how many games this season and how many games next season. If it's the same number of games, then it's okay, but otherwise, no. Okay, if elected, a politician promises to cut taxes by 20% for each of the first 3 years for a total of 60%. Well, that's going to be a shifting reference value. Okay. Because you're going to take 20% off of the original, but then your reference value becomes the reduced price and so on and so forth. An advertisement claims that the energy efficient bulb uses 200% less energy. That can't happen. If it was 100%, then it would use no energy at all, but that's not what's going to happen. Okay, and this one is really, really common. A stockbroker makes the claim, I admit the value of your investments fell 60% last year. This year, however, their value increased by 75%, so you are now 15% ahead. This, again, is a shifting reference value. Okay. They're calculating the 60% off of what you started with. That changes the reference value to the lower amount, and you're calculating the 75% on that. I've decreased my calorie intake by 125%, which has helped me lose weight. Yeah, you can't do that. The most you can reduce your calorie intake is by 100%, which means you're ingesting no calories at all. You can't ingest fewer than 0. Okay, so that talks about abuses of percents.